It's the third portion of 7.1. We'll talk about an example of a normal random variable. So if a continuous variable is normally distributed, we've said, then the relative frequency histogram has the shape of a normal curve, meaning bell-shaped and symmetric. Therefore, a normal random variable is a variable that is continuous and whose relative frequency histogram is symmetrically bell-shaped.
All right, so let's look at a normal random variable and how it is distributed. The data on the next slide represents the heights of random sample of 52-year-old males. So 52-year-olds. Let's look at the histogram and then talk a little bit about whether it's normally distributed or not.
So here is the raw data of the height in inches of the random sample of 2-year-old males. And this is that data translated into a relative frequency histogram. So looking at this relative frequency histogram, we would say the shape of this is roughly normal.
Histogram. So there's the histogram drawn from that data. We know how to draw histograms. And this is a relative frequency histogram. So the relative frequency histogram is a vision of the probabilities, basically, because you remember that probability model or probability distribution is a relative frequency distribution. Okay, so looking at this, look at the rectangle between 34.5 and 35.5. Is it exactly the same as the normal curve? No. However, that rectangle between 34.5 and 35.5, how do you think that compares to the area underneath the curve between 34.5, oops, right here, and 35.5? How do you think that rectangle's area compares to what I'm shading right now? Okay. How does the green compare to the shading I'm doing right now? Well, the area of the green rectangle between 34.5 and 35.5 inches, and the area that is shaded underneath the curve between 34.5 and 35.5 is approximately the same. So what does the area under a normal curve represent? If our random variable x is normally distributed with a mean mu and a standard deviation of whatever the sigma is, whatever our standard deviation is, the area under the normal curve of an interval of values for the random variable x represents one of two things: the proportion of our population with the characteristic that we're describing. In that last example, it would be proportion of the 2-year-old males that are between 34.5 and 35.5 inches. Or another thing that it could represent is the probability that if you selected one 2-year-old male from the population, the probability that that person would be between 34.5 and 35.5 inches would be that area.